Okay, let me solve the problems I did in lab again, and to explain you, if you're interested in looking at it yesterday at the lab, probably some of you didn't understand it all exactly what we do. Just a review. If you want to review it, it's always good. So a 43.29 grams of sample of a solid, right? So we got the mass of the solid would be equal to 43.29 grams. It's transferred from boiling water, so that means that the initial temperature of the solid, how do you know? Because the solid was in the boiling water. So on the temperature of the boiling water, like we did in the lab yesterday, it's degree Celsius. Two, so that means that I'm gonna mix two systems, one the solid and the other one water. Okay, and the mass of the water would be equal to 152 grams, and the temperature of the water, the temperature, initial temperature of the water would be 22.5 degrees Celsius. The final temperature would be 24.3 Celsius. Now, when you got a system that has two parts and it's an isolated container, degrees Celsius. So, and calculate the specific heat of the solid. And this is mixed in a calorimeter. It's called, and it's the styrofoams that we do, the styrofoam cups that we did in the lab. So if you got a calorimeter here, right, and you got here water, and this water is at 22.5 degrees Celsius, right, and 22.5 degrees Celsius, and the mass of the water, and this is the initial temperature T1 of the water, of this water here. And the mass of this water, what's going to be? It's going to be 152 grams. Now, if you add a solid, a hot solid here, right? Let's put it like that. This solid has a mass of 43.29 grams. And it has initial temperature, right? Because that's the one you're getting it out from a boiling water, 99.8 degrees Celsius. Now, if you get this solid, at a higher temperature, there's going to be a flow of heat until they reach an equilibrium. That is called the zeroth law of thermodynamics. It means that in an isolate system, right, the heat from one part of the system, which is the solid, is going to be transferred to the other part of the system, which is the water, until they reach a thermal equilibrium. So the final temperature always in this type of system, isolated system, when there's heat transfer to one to another one, it's always the same for both. See how I said you put you have a Diet Coke, you put the ice. In the case of the Diet Coke and the ice, the Diet Coke is transferring the heat to the ice until both get to the same temperature. That's reaching a thermal equilibrium, it's called. Okay, you can, the heat is transferring. So basically, there's two important things. Know that, well, of course, endo and exo. Endo would be a positive sign, Q would be positive, and exo negative. And also another thing, that endo Endo means um, absorbing heat, absorbing words like that. Exo releasing heat. And um, exo and endo. And the other important thing is that, well, the heat has to be transferred from one part of the system to another one. Well, okay, so the heat of the system 1 is always equal to the heat of the system 2. Now, 1 has a negative sign, of course, because 1 is releasing the heat and it has the negative. Which one will have it? The one always that has the higher temperature. Let's put it here, optional. But it's always the negative sign for Q in system of higher temperature. Why? Because the flow, think about it, because the flow of the heat is from hottest to coolest. So from the hot to the cool. So the flow is gonna go, the heat flow is gonna, the heat transfer is gonna be endo when it's colder because it's receiving the heat from the hottest part of the system. So if we plug in the Q1 and Q2 in this case, would be the Q of the solid equals the Q of the water. Now let's look which one is going to have the negative sign. Which is at a higher temperature? The solid. So always remember it's going to have a negative sign. So the Q of the solid would be equal to the Q of the water. Let's put the formula for each one. By the way, the specific heat of water is 4.184. I forgot to give you, but it's always that for water. You don't have a problem never with water. You know the specific heat. So the specific heat. So let's plug in the formula. Minus, and let's leave the negative sign, the mass of the solid, right? Multiply by specific heat of the solid. That's what we're trying to find out. Multiply by the final temperature, TF, minus initial temperature of the solid, equals the mass of the water, right? But there's no negative sign here, plus the multiply by specific heat of water, multiply the final temperature minus initial temperature of the water. Now let's look at our equation. They're giving me the mass of the solid is given. This one, let's call it X. They're giving us the final temperature, which is 24.3. They're giving us the initial temperature of the solid, which is 99.8. The mass of the water, the specific heat of the water, we have it. Final temperature 24.3 and initial temperature of water 22.5. So let's plug in our values and let's leave it as X. So this is going to be minus 4329 grams multiply, I put it like this, multiply by X, multiply, what is the final temperature of both? 24.3 degrees Celsius. And what is the initial temperature of the solid? I can show you, but 99.8. And remember, all this has a negative sign. So this is going to be equal the mass of the water. What is the mass of the water? 152 grams. Multiply by specific heat of water 4.184 joules per grams per Celsius. And the difference in temperature, right, would be TF, which is 24.3 degrees Celsius, and the initial temperature of the water, if you remember, 22.5 degree Celsius. So let's start solving an equation. And just to show you the difference in temperature in the initial temperature of water, you see 22.5. So let's start solving this, right? Minus 43. Let's go ahead and solve this parenthesis first. So 24.3 minus 99, it gives me 75. So we got minus 43.29 grams x multiplied by minus, because this difference is minus 75.5 degrees Celsius. This is Celsius. Equals, let's do our numbers here. 152 grams multiply by 4.184 joules per grams per Celsius. And here on the right, 24.3 minus 22.5 is 1.8 degree Celsius. Okay, so the grams and grams cancels out. Degrees Celsius and degrees Celsius cancels out. We only have that on the right. So here we got, if we have a negative sign here and all this is multiplication, negative, and negative goes positive. So 43.29 grams multiply by 75, because I took it, I canceled the negative sign. Celsius, and all this multiplied by x. So let's solve this right part. We can we can do all this multiplication, and this is gonna be 1,000. It's gonna be, you can do it by step, multiplying this and this first, which is gonna be 635.968 joules. This all multiplied by 1.98, by 1.8, because we already canceled out the units. So this is giving me on the left side, we multiply the 2 here, and it's gonna give me 3,268.395 grams multiplied by degrees Celsius are the unit, and all this by x. That's what we're trying to find out at the unknown. Here is 735.968 joules multiplied by 1.8 gives you 1,144. This gets confused with that. 44.7424 joules. Now, you got on the left side this. Now let's divide everything. So what we want to do is leave this x by itself. So we're going to divide everything by 3268.395 grams Celsius divided by 3268.395 grams per Celsius. So this and this cancels out. So our x, which is our final temperature, is gonna be, right, 1,144. It's gonna be 0.350246, and if we look at the units, it's joules per grams per Celsius. Joules per grams Celsius. And this, how many sig figs do we have in the problem? We have 152, 232.5, all of them are 3 sig figs. This is 4, but it should be given in 3 sig figs. So 1, 1, 2, 3. We have to drop the 246. So it's going to be 0.350 joules per grams per Celsius. And that's the right answer. And this is our specific heat of the solid. Let's go with this problem number 2. Problem number 2 says if 100 grams of liquid water, so we got one system here. Let's start with system number 1. And we got mass is 100.0 gram and it's water. Okay, and the system 1 is saying. And the initial temperature of this system, of system 1, 1, 1, is gonna be 100.0 degrees Celsius. Okay, now we mix that with 200 grams, so we got again water, and we mix it with 200 grams. This is the mass of system 2. So we're gonna mix it with mass 2 equals 200 point grams of water 2, 20 points, and at initial temperature of system 2 would be 20.0 degrees Celsius. So they're asking for the final. You know that it's the same, right? Final temperature is going to be the same for both. And let's call it X. So again, we do our equation, which have to have the negative sign. The one that initially has a higher temperature because it's releasing the heat. So the mass of the system 1, this would be minus the mass of the system 1, multiply specific heat of water, multiply by TF, which we're going to call it X, minus initial temperature, which is 100.0 Celsius, equals 200, because it's the 200 grams. I'm plugging in everything at once. Let me do it first, the formula, and then we'll start plugging in. So I was saying X, which are our final temperature, minus initial temperature of the system 1, equals the mass of water of the second system, because both are water, multiply by specific heat of water, multiply by the final temperature minus initial temperature of system 2. Now, if you look at it, let's plug in the numbers. But before we start, you got two equations in which they're multiplying here. Not this one. Is this specific heat, and it's multiplying this and multiplying the whole binomium. Okay, and this, let's do it with the x. M1 by specific heat of water multiplied by X minus T11, right, equals M2 by specific heat of water by TF minus T12. Okay, now let's plug in the value. What is the mass of the system 1? It was 100 grams, right? So it's going to be 100.0 grams multiplied by specific heat of water. That's what I was saying before I started to plug in the numbers. If we have two equations in which the specific heat is multiplied is the same, just cancel it out. Period. Cancel them out. But it has to be the same on both systems, the same if it's water, water. So this would be, you divide everything by SW, right? by system, the specific heat of water. So now you multiply by x minus initial temperature of system 1, right? And remember this has the negative sign here, equals mass 2 is 200 grams multiply by x minus initial temperature of 2. Now let's plug in the temperatures. And another thing, what if I divide, remember this is multiplying the whole binomial. Why don't we divide by 100 both? You see, if you divide both sides by 100, as this is multiplication, you can cancel them out. And by the way, it's not 100 grams, it's 100. I cannot divide it on this side to divide units to, it's 100. So you got 100 divided by 100, right? And here you divide it by 100 too. So it's gonna give you 100 and 100 cancels out, minus 1 gram multiplied by x minus what is the initial temperature of 1? Should be the higher, 100.0 degrees Celsius. Equals, you cancel out the 0 and it's going to be equal 2 grams multiplied by x minus what is the initial temperature of system 2? Is going to be 20.0 degrees Celsius. So what we have to do is now we do the distributive property, minus 1 gram multiplied by x, minus 1 gram multiplied by x, okay, minus 1 gram multiplied by minus 100 is plus 100.0 grams per Celsius, equals 2 gram multiplied by x, then plus and minus 40 because I multiplied the 2 by 20.0, 40.0 degrees Celsius. So grams, that's what happened when I do things at 2 grams multiplied by 40 degrees Celsius. So let's add 1 gram in both sides, right? So that way we get rid of the gram. And if we want to get rid of this 40, let's add 40 on both sides. Yes or no? So 1 gram, so we're going to add on the other side the same 1 gram x. Don't forget the x, plus 40.0 grams per Celsius. So adding this together, right? 40 grams Celsius cancels out on this side, minus 1 and plus 1 gram cancels out. So it's gonna give you in the x2, the whole term cancels out. It's gonna give you 140 1 decimal point 0 degree equals grams per degree Celsius equals 1 plus 2, 3 gram x. Now grams and grams cancels out. So you're going to have 140.0 degrees Celsius divided by 3 and gives me the final temperature. And this is going to be 46.6666, I think. Yeah, 46.6666. Okay, degree Celsius, we take it to 3 sig fix. Why? Look at the problem again. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. We don't care about the 4, we care about the minimum amount. So it's gonna be 46.7 degrees Celsius.